Hello, class. I'm going to do a recording now for Chapter 12, Section 6. It's called Multiplication with Polynomials. So I'm going to share my document camera with you now. Okay, so we're going to go over 12.6, Multiplication with Polynomials. And we're going to start with the workbook problems on page 261, section 12.6. So the first three problems are really like a review of chapter 12, section 1. So these are really a review of chapter 12, section 1, where you're using the product rule. So remember, that says that you basically want to keep the base and you want to add the exponents. And you're also going to be doing some multiplication. You're going to multiply the coefficients. Okay, so that was back in section 12.1 when we first started learning. We're already in 12.6. So we first started learning about the exponents and their rules, except we're going to do that repetitively, this idea repetitively for this new section 12.6, multiplication with polynomials. And then we're also going to be like adding like terms. Okay, so we're going to be doing that like starting with problem 4 and so on. Okay, so here, this is really like a 4 times an imaginary -1, which is a -4. And with the x's, you're going to add the exponents, the like x bases 2 and 3, give you 5. And then you just have that singular y, which you can't forget about. Okay, so this is a monomial, and the degree is 6, because you're adding this 5 and this 1, which gives you 6. And the leading coefficient would be -4. So that's all practice. That's all practice also from past lessons that we've learned, review of that. Okay. Okay, number 2, this is, you're going to use, yes, you're going to use the product rule again, but this idea is also distributive property. Distributive property. So X is your distributor. There's an imaginary 1 here, which gets distributed, right, to all of your terms, right? So you have this 3, because this is an imaginary 1 also in the front, and on the X, it's 1 plus 2, right, which is 3x cubed. And then you have plus 7, and on the X, 1 plus 1, which is 7x squared. And you have plus 8x. That's cube, squared, and then x to the first power. This is a trinomial. The degree is 3, because it's this 3 is bigger than this 2, bigger than that 1, right? It's a 1 there, right? And the leading coefficient is this 3, because of this right here. Okay. So you don't try and add 3 and 2 and 1. The only reason why we added over here is because this was a monomial. All this was one term, right? We don't do that here because you have the plus and minus terms that they're separate. Okay, so it's just 3 is the biggest exponent, largest exponent per term. 3 is the largest exponent per term, because this is a squared and that's a 1. Okay. Okay, and then on this one, this is also distributive property, except it's just, you know, on the back end side. We're used to seeing it in the front end side, but they can put it on the back end side. So this is 5 times 5, which is 25 on the x2 plus 1, which is x cubed. And then plus 5, because this is, you know, times imaginary 1 there. So that's just 5. And then xy. So let me just not put it here. Let's put it here. So I'm not rewriting it over and over. This is just 5, and then alphabetize. This alphabetizing x's come before y's. Don't put yx. It's not alphabetical order. Put 5x. This is a binomial. The degree is 3 because this 3 is bigger than this 2. This is 1 and 1, which is 2. The degree of this is 2. This beats this. So the degree is 3, and the leading coefficient is going to be that 25. Okay, because of this. Okay. All right. So that's like those are like a review just to get warmed up. Okay. And then the new ideas come with the ideas of like FOIL, box method. You're multiplying a binomial times a binomial times a trinomial. So those are the new concepts in 12.6. So right now we look at number 4. This is binomial times a binomial, and I'm going to use FOIL. So this is 2 binomials, and I'm going to use FOIL, FOIL. And FOIL is used on the product. Product is something you do when you multiply of just 2 binomials. Not a binomial times a trinomial, just a binomial times a binomial. And F stands for you multiplying the first terms of each binomial. Okay, so we're doing, for example, x times x. So x to the first power times x to the first power is x1 plus 1, which is x squared. And that's part of your answer here for the leading term, or I should say for the first of 3 terms is x squared. Okay, and then O stands for you multiplying the outer terms. And a lot of times teachers will do this. They'll draw like these arrows. A lot of times they'll do this, inside, outside terms. So you're doing basically 8 times x. Well, really you're doing x times 8, but you're not going to write it x8. You're going to write it 8x. They like to put the coefficient in the front and the variable in the back. This kind of looks awkward. Okay, multiplication is commutative. And then you're going to multiply the inner terms. So oftentimes teachers will do this, arrows inside, inner terms. So we're doing 1 times x, which is just 1 times x, which is just x. We don't put the 1, it's imaginary, right? Okay, and then these happen to be like terms. If you have like terms, and 90% of the time you will in FOIL, if you have like terms, you'll see them on the outer and the inner. If you have them, you'll still show up. And like terms need the same base and the same exponent, need the same base and the same exponent. And those are like terms. So 8x and x is a total, if I add those up, of 9x. So those are part of your answer. You have this x squared. Now you have this 9x plus 9x. Descending order. This is called descending order. So you have x squared and then x to the first power and then constants last. So L stands for multiplying the last terms. So we're talking about multiplying that 1 times that 8. And those are positives. See, those are positives. So 1 times 8 is 8. And that's part of your answer here, plus 8. Okay. So that's called FOIL, first, outer, inner, last. It's called FOIL, okay? All right, now, so pause the video if you need to pause if you're still writing, but we're gonna get ready to look at page 262, and we're gonna do number 5, but I'm not gonna do FOIL on it. I'm gonna show you another method in case you'd like to do that. It's called the box method. And you can choose when you show your work, you can use distributive property, you can use FOIL, or you can use the box method. You have some choices. So I'm going to show you kind of all 3 of them, and then you get to choose which one you like. That was FOIL. Okay, so now on number 5, this is also where you can, on number 5, you can use FOIL or the box method or distributive property. On binomial times binomial. So you get to choose. So I'm going to just show you now the box method for number 5. And with the box method, you just draw like a, in this case, a 2x2. And because you do a binomial times a binomial, so you see, and you put one binomial across the top. So I'll just put the 2x here plus 1. And then you drop the other one to the side. So I'll just put the 3x to the first power here minus 6. Or vice versa. If you wanted to put the 2x plus 1 here and the 3x minus 6 there, you could. But you put 1 across the top. So you see, this is where our answer is going to go. So I write 1, I write a binomial across the top and along the outside. That makes sense? I write one across the top and I write the other one along the outside. And then teachers, the reason why this is like a favorite of high school teachers, it's a favorite because they're usually concerned about students forgetting a product. But with FOIL, it's hard to forget because you have FOIL, so there's 4. And with the box method, it's hard to forget because you won't leave these cells vacant, you'll fill them in. And then you still have to combine like terms, okay? So here you're doing 3x times 2x. So you want to show a little bit of work. You're looking at 3 times 2, which is 6. And then the x, remember, you have to keep the base and you have to add the exponents. So that gives you x squared. So that's going to be your first term in your answer. And then if you have like terms in FOIL, if you have like terms, you see it on the O and the I. In the box method, if you have like terms, you see it along the diagonal. Like terms, and I should say any, because you don't always have like terms. 90% of the time you do. Any like terms are visible along the diagonal. So 3x times 1 is just 3x, right? So 3 times 1 with respect to x, that's 3x times 1. And then -6 times 2x. -6 times 2x is -12x. So -6 times 2x is a -12x, okay? So here we have like terms. -12x plus 3x, that gives you a total of -9x. Or if you -12x plus 3x, you could put that here also, is 9x, okay? But that is the second term in your answer is, and it's going to be either positive or negative. You connect terms with signs, positive or negative. This is positive 9x. And then you have -6 times 1. -6 times 1 is -6. Okay, so that's your result for that. Okay. So that's a trinomial. That's a trinomial. Okay, the degree is 2 and the leading coefficient is 6. Okay. Okay, so that's called the box method. Okay, and then now on number 6, I'm gonna show you the distributive property. I'm gonna show you the distributive property. And this is a trinomial. This is a trinomial times a binomial. So you definitely cannot use FOIL on that. FOIL is only a binomial times a binomial. So you have a choice. On this one, you can either use distributive property, or you can use the box method. So I'll show you the box method for number 7, because number 7 is also a binomial times a trinomial. So I'll show you the box method on 7, but on 6, I'll show you the distributive property in case you prefer distributive property. So usually what happens with the distributive property, usually I tend to make the shorter poly the distributor. So I tend to make the shorter poly the distributor. So the trinomial has 3 terms and the binomial has 2. So I'm going to make this x minus 6 the distributor. So I'm going to make x minus 6 the distributor. So when I set that up, the x, I'm going to put it like right here, for example. And then see the minus 6 and put that right here, for example. See that? And I make that the distributor. X is going to be multiplied times all this trinomial, x squared. And you can put the 1s here if you want to emphasize that. 1x squared minus 1x to the first power minus 3. Let me just close this. And then minus 6 times all of this. 1x squared minus 1x to the first power minus 3. Okay, so we tend to make the shorter polynomial the distributor. So you make x minus 6 the distributor, okay? And you're going to start multiplying, 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 okay? So 1 times 1 is just 1, right? And then you keep the base and then you add the exponents, right? 1 plus 2, that gives you x cubed, okay? 1x to the first power times negative 1x. So positive times a negative is a negative. And then the x, you're keeping the base of x and you're adding these little exponents. So that's negative x squared. Okay. And then 1x times negative 3 is just a negative 3x, right? So it's negative 3x. Okay. So basically this gives you x cubed minus x squared minus 3x, okay? Now you have to do the same thing on this side. Negative 1 times 6x squared is negative 6x squared. Negative 1 times negative 1x. So negative times negative is a positive 6x, okay? And then negative 6 times a negative 3 is a positive 18. So remember, same signs produce positive results. Different signs produce negative results. Remember, that's what we called rule number 4, and that's when you're multiplying 2 at a time, or multiplying or dividing. We're not dividing, but if you were dividing 2 at a time, we're not dividing here, but if you were dividing also, same signs produce positive, different signs produce negative. So we're not dividing here, we're just multiplying, but I'm just reminding you that that's rule 4. Same signs produce positive, different signs produce negative, okay? But now you've got to combine like terms. So now you're going to have to combine like terms, okay? So, and then I'll put the answer up here. Okay, so first of all, you have this x cubed that's flying solo because this one doesn't have any x cubes. But when it comes to the x squares, you'd have a pair of them, this one and this one. So you got to combine those. So if I do a little scratch work here, negative 1x squared plus negative 6x squared is a negative 7x squared. So that is another part of your answer here. negative 7x squared. And then after it descends down, x cubed, x squared, now x to the first power. So you have negative 3x and a positive 6x. So a negative 3x and a positive 6x is just a 3x. And it's positive 3x. And then constants last. And this one's fine, solo plus 18. Okay, and then that would be your answer. X cubed minus 7x squared plus 3x plus 18. Okay. 1, 2, 3, 4. That has 4 terms. That's a polynomial, 4 terms. They didn't call it a quad for 4. They didn't give it a Latin prefix. They just call it a polynomial. Okay. All right. So that's distributive property if you like that. The other thing I was going to tell you about distributive property, I'm going to show you in the back. This is setting it up horizontally. I have seen some books set it up, you know, like this. Let me just show in the back. I have seen some books set it up like this, like they do x squared, 1x squared minus 1x to the first power minus 3, and they do this times 1x to the first power. I've seen that. 1x squared minus 1x to the first power minus 3 times negative 6. I have seen books before set it up like that. So if you don't like the horizontal, this is the horizontal, x times that, see, x times this whole trinomial, x times this whole trinomial, negative 6 times this whole trinomial. If you don't like set up like that, I've seen it like this, x times the whole trinomial, negative 6 times the whole trinomial. So if you like that better, you can set your work up like that. That's also distributive property. And that would just go this way, right? 1x times negative 3 is negative 3x. 1x times negative 1x is negative x1 plus 1, which is negative x squared. This is negative 3x. And then 1x times 1x squared is 1x2 plus 1, which is x cubed. So x cubed minus x squared minus 3x. I don't know if you think that's easier or not, but that's another way you can do it. Negative 6 times negative 3 is 18. Negative 6 times negative 1x is a positive 6x. So the thing is, you have to put your sign so in between them, pluses or negatives. And then negative 6 times 1x squared is a positive 6x squared. Okay. And then you would just combine like terms, the way we were doing, you know, over here, combining to get that. Okay, so you can, if you like that, you can freeze the camera and write that down if you like that. Okay, and then personally, my favorite is though the box method. I like the box method because it is kind of hard to keep all that organized, and I have to use markers and colors to help me. Otherwise, I can make mistakes. I like the box method, but you'd have to draw a bigger box than this. This is for a 2 by 2. Now you're going to draw a 3 by 2. So you would have to draw a bigger box. And you'll see on your practice test templates that I usually have the boxes drawn up in case you want to use them. I already have them drawn up on the Word. And if you don't want to use them, you just work around it. You show your work, you know, around it. But I have them set up already in case you want to use it. And I would write the trinomial across the top, negative 3x squared plus 1x to the first power minus 3. I write the trinomial across the top, and then and just like I said over here, write like a binomial across the top, and then along the outside, I do something like this. I write the trinomial across the top, and then I drop the binomial to the side here. Okay. And then we start multiplying. So 4x times negative 3x squared. So 4 times negative 3, 1 plus 2, that's negative 12x cubed. 4x times 1x, 4 times 1, and then x, and add those up, 4x squared. 4 times negative 3 with respect to 12 is negative 12x. Okay. And then if you see like terms, you'll see the like terms along the diagonal. So like here, you'll probably have like terms. Here, you'll probably have like terms. So watch what happens here. When you do 3 times negative 3x squared, that's a negative 9x squared. So you see how you have like terms right there? See that? So negative 9x squared plus 4x squared is negative 5x squared. So it's negative 5x squared. So you have 12x cubed and you have negative 5x squared. Okay, so let's see my answer. It's going to squeeze it here. So I have negative 12x squared, negative 5, oh, excuse me, negative 12x cubed, negative 12x cubed, and then negative 5x squared. So you see it's descending power. X cubed descends down to x squared. Now descends down to x to the first power, and then constants go last. So here we're doing 3 times x is just 3x. So you see you have those like terms right there. Negative 12x plus 3x is negative 9x. And then constants last. 3 times negative 3 is a negative 9. Okay, so 1, 2, 3, 4. So you got 4 terms there. So that's called descending order. Descending order. Okay, and that's the box method. So I like it because I think it's a little more organized than this, but whichever is best for you, whichever is best for you is fine. Okay, so let's see what else do we have. I think the book likes to push the distributive property. When I'm looking at the learn, when I look at the learn, it looks like they like to push the distributive property. Okay, and let's see what they say about some of the true and false. Let's see. Let's see here. Okay, I see some true and false at the bottom of page 257. And look at those. Let me just, I'm trying to see if I had one more page of work worked out. I don't think so. I thought I had. It's not. That's the next section. Okay, just double checking. It doesn't look like it. Okay. All right. Okay, so let's see what they sound as true and false here. So it says that the distributive property can only be used to multiply a monomial and a polynomial. Yeah, that's false. That says that's false. The distributive property can be used when multiplying any types of polynomials. Yeah, yeah. So like multiplying a binomial times a binomial or a binomial times a trinomial. So distributive property can be used when multiplying any types of polynomials. So like binomial times a binomial or a binomial times a trinomial. Okay. What's restrictive is like FOIL. The distributive property is not restrictive. Distributive property is not restrictive. What's restrictive is like FOIL. FOIL is limited or restrictive to only a binomial times a binomial. So FOIL is the only one that's restrictive, but not the distributive property, and also neither the box method. The box method really could be created or used on a binomial times a binomial or binomial times a trinomial. Even a monomial times binomial, you just have like one line of box. So let me show you that. Like if you wanted to do the box method on something like that, let me just show you this. Like this is page 258, number 4. If I wanted to do the box method on this, a single box, something like this. So I have, see, like 2x cubed plus 5x to the first power times negative 3x squared. So you see, I could do a single box, binomial times a monomial. This is a box method. So this would give you negative 3 times 2, and on the x, 2 plus 3, so that's negative 6 x to the 5th power. I just probably should have made a bigger box, so I won't cram all that in. Maybe be more generous with my box. But you see, negative 3 times 5 on the x, 2 plus 1. So let me make this bigger. Okay, so I could have been more generous with my box and made it bigger. That's negative 15 x cubed. But there's your answer there. Your answer is the negative 6x to the 5th, and then the negative 5x to the cube. And so that would be your answer, negative 6x to the 5th minus 15x to the cube. So that there I'm making a box out of that, a binomial times a monomial. Okay. All right. So you can freeze it if you need to pause it, but I'm going to go back to this true and false. Okay. All right. Number 2, the product of A plus B and C plus D is A times C plus B times D. and they're saying that's false. They're saying that it should be the product of A times B, the product of A plus B and C plus D is equal to A times C. So I can make that bigger. So they're getting that from this A times C. They're doing this A times C. So that's like, you know, that's like the first, that's like your F, the first. And then plus A times D. So that's this A times D. So that's like, so that's outer. So that's like first and then outer and then plus B times C. So that's inner, and then last, which is B times D, positive B times positive D. So this is a little bit easier because they're all pluses, but it's kind of like the idea of FOIL, first, outer, inner, last. But yeah, it's just not A times C and only B times D. It's just not that. You need the outer and the inner. You need 4. See, 1, 2, 3, 4. You need 4. That's why I like the box method, because if you do distributive property, sometimes you miss out. So you put 1 across the top, and then you drop 1 along the side. A plus B across the top, and then C plus D. You put 1 binomial across the top, and then you drop the other binomial to the side, and then you're multiplying. See, A times C, and then B times C, and then A times D, or you could say DA, and then D times B, or they put, if I put it like them, B times D. But really these are commutative, right? But that's kind of where they're getting that from. So AD is the same as DA, right? BD is the same as DB, but that's the idea, okay? So what happened here is they only did 2. They only did 2 products. You need 4. 1, 2, 3, 4. 1, 2, 3, 4. And that's a mistake students make when they're learning. They don't do enough of the product. So just be careful. And then number 3, the FOIL method is a way to remember one specific order that the distributive property can be applied. Yeah, that's true. That's what I was doing. First, they read my mind. First, outer, inner, last. So yeah, it's another way to set that up. Okay, so that's fine. Okay. All right, then I believe that's the lesson. That's the lesson for this section. Okay, so good luck with your studying. I see. I was going to actually just show you this if you want to work this on your own. This is page 258, and you now have an answer key, 258. So if you want to pause the screen, I have a little answer key. So this should be the answer that you get for that. So you can write that down or pause the screen. This is on page 258. This is the answer when you do number 6. Okay, again, this is page 258. So there's number 5. There's number 6. And there's number 7. Okay, so they don't show you the work, they just have the answer. So I'm gonna do that in case you want to freeze it, write it down, then you can work it on your own to check your answers, okay? But good luck with your studying.